Hello students, in this video we are going to continue with chapter 11, Work and Energy. In the previous video you have seen how to define work. We have seen two definitions of work basically. One, as I have written here, work done is defined as the dot product of force and displacement, and work is a scalar quantity. Here work done is equal to Fs cos theta. This definition is not given in your 9th class, but you should know it for the better understanding of the chapter and also of this topic. But in your 9th class, what definition you are going to remember is W is equal to F into S. Work done is defined as the product of magnitude of force applied and magnitude of displacement produced in the direction of force applied. You know work is a scalar quantity. You know its SI and CGS units are joule and erg. You can define them, you can convert joule into erg. Now let us see types of work. So first we'll consider the basic equation, the real definition and formula for work done, which is W is F bar dot S bar is Fs cos theta. We know that F is positive because it is a magnitude of force, S is positive. So let us just concentrate on the cos theta. Now, when two vectors, force and displacement, are in the same direction, theta, which is a smaller angle between force and displacement, is 0 degree, and I think so you know the value of cos 0 is 1. When the two vectors, force and displacement, are perpendicular to each other, theta is 90 degree and cos 90 degree is 0. When the two vectors, force and displacement, are in the opposite direction, then theta is 180 degree and cos 180 degree is minus 1. Hope you have by hearted these values of cos for these three angles. Now, as we can see here, that when the theta lies in this range, when the theta is lying in this range, that is, it is less than 90 degree, then work done will be positive because cos will be positive. You know for theta less than 90 degree, that is when angle between force and displacement is acute, theta is less than 90 degree. What will be the value of cos theta? It will be either 1 or 0 point something or positive. Okay, so we can say from here that positive work is done when the angle between force and displacement is acute or less than theta is less than 90 degree. Work done will be positive and W will be equal to F into S plus F into S. It will be for when theta is 0 degree. For other cases, it will be less than that. Okay. So what is the maximum value of positive work? That is when cos, you know that cos maximum value is 1, positive 1. So W is equal to Fs when theta is equal to 0 degree. It is a maximum positive work done. And we also know that when theta is less than 90 degree, then also work done is positive. Now let us consider this range. When theta is greater than 90 degree, it means when force and displacement are inclined such that angle between them is obtuse. Then in that case, cos theta, see here, will be lying in this range. It will be more than 0 and less than minus 1. It means cos theta will be negative. So when cos theta is negative, work done will also be negative. So we can say when angle between force and displacement is greater than 90 degree, then work done is negative. And when we say that the maximum negative work, here we'll not talk about the simple maths where we take minus 1 to be smaller than minus 0 point. Okay, so maximum negative means minus 1 only here. So when we say maximum negative work is done, when is maximum negative work done? When theta is equal to 180 degree, cos theta is minus 1, and in that case maximum negative work is done, and that is W is equal to minus F into S. So last case, when force and displacement are perpendicular to each other, cos theta will be 0 because cos 90 is 0. In that case, we say work done is 0. So on the basis of cos theta, we have three types of work: positive work, negative work, zero work. When the angle between the two vectors is acute, work done is positive. When angle between the vectors force and displacement is obtuse, that is greater than 90 degree, work done is negative. When they are perpendicular to each other, work done is zero. But this is all on the basis of this equation. Now let us see what you have to remember in your 9th class for these three types of work done. Now, as per your NCERT textbook, they have given this about positive work. Positive work. When force and displacement are in the same direction, work done is said to be positive. And W is equal to plus Fs. As I have told you, when you look into your NCERT textbook, cos theta is not mentioned. So they are not mentioning anything about angle. They are just saying, when force, they are not mentioning anything about actually cos of an angle. When force and displacement are in the same direction, work done is said to be positive and W is plus Fs. This is just what you are supposed to write when you are asked what is positive work. Okay, but now as you all know this equation, the basic definition of work, you know that work done is positive for this case, and it is also positive when the angle between force and displacement is acute. This is the extreme case. This is a maximum positive work done when force and displacement are in the same direction. Okay. So we'll study this only now, but although you can remember, for all acute angles between force and displacement, work done is positive. But now that you can write in your 9th class, for your 9th class answers, positive work is said to be done when force and displacement are in the same direction, and W is equal to plus F into S. Now let us see examples of positive work. See, when a body falls freely under gravity, whether you have dropped a body or whether you have thrown a body down. Okay, so whenever a body falls freely under gravity, work done by gravity is positive, because you know, when a body is falling freely under gravity, it is falling downwards. Then in that case, gravity is always acting in a downward direction. So work done by gravity is positive, because gravity, that is force due to earth, is in the downward direction, and even the body is falling vertically downwards. So force and displacement are in the same direction, and we can write work done by gravity is positive. Okay. Now, second example here I have written. Suppose if you have a spring and you stretch it. Let us say the spring is extensible, flexible. Okay. So when we apply force to stretch a spring gets stretched in the direction of force applied. So work done by the stretching force is positive. Okay, because you see the end of the spring that gets moved in the direction of the stretching force applied. So force and displacement are in the same direction. Work done by the stretching force is positive when we stretch any spring. Now, the third example here I have taken is, see, this is rough diagram I have drawn for a lawn roller. Okay, which is used in the gardens to just trim the grass on the garden. Okay, now here the lawn roller is this type. Its handle, generally we pull the handle in this direction towards ourselves, and then this roller gets moved and it does its work. So in this case, when we pull the lawn roller, the force applied and the displacement produced, the angle between them is acute. And we know that this angle is, whenever it is acute, work done is said to be positive. So when we pull a lawn roller by applying force on its handle, work done is said to be positive. This is actually based on this. So when you have the knowledge of that cos theta is positive for all acute theta, then only you can understand this example. Similarly, we can write, when you open a drawer, okay, when you open any drawer, you pull it towards yourself and the drawer gets displaced in your direction or in the same direction. So when we open a drawer or close a drawer, work done by the applied force is always positive. Hope you have understood what is positive work. You can define it, you can give examples for it. So we'll continue with this topic. We'll continue with this topic means we'll do negative work and zero work in our next video. Hope the topic is clear to you. Thank you, students.